Alright, so we are going to be looking at evaluating functions. Now, when you see the word evaluate, that literally means solve. So what you're going to do is you are going to solve. So what we're going to do is we're going to go ahead and solve this function. We're going to create a table first for our x and y values. It says we need to use 0 through 4 for our x values. We're going to plug those in for x in our function and then get a y from there. So if we plug in 0, we get 2 times 0 squared minus 10, which is 0 minus 10, so that is a negative 10. And that's going to be my y value. If I plug in a 1 next, that's 2 times 1 squared minus 10. So that is 2 minus 10, negative 8. And then the negative 8 goes there with that one. If I plug in the 2 next, 2 times 2 squared minus 10, that is 4 times 2, that's 8 minus 10, so that gives you negative 2. And then, there we go. All right, and then if we plug in 3, 2 times 3 squared minus 10, so that's 9 times 2, 18 minus 10, that gives you 8. And then the last point is a 4, so plug in that 4. 2 times 4 squared minus 10. That is 32 minus 10, gives us 22. And that is it for this problem. Don't overthink it. Trust your gut, trust your instincts. Plug those x values into your function to get a y value. All right, so we are going to copy and complete the table to evaluate the function. Once again, evaluate means solve. So on your guys' papers, you will copy the tables down. Starting with number 1, we've got 3 minus 2 to the x. We are going to plug in 1, 2, and 3 for our x values. So starting off, I have 3 minus 2 to the first is 1. 3 minus 2 squared, which is 3 minus 4, is negative 1. And then 3 minus 2 to the third, which is 3 minus 8, is negative 5. Not too bad. Let's go ahead and take a peek at this next one. So we've got 5x squared plus 1. So you're going to make sure to put parentheses around that x. So 5 times 2 squared plus 1, which that is 5 times 4 plus 1, which is 21. Then you've got 5 times 3 squared plus 1, 5 times 9 plus 1, which is 46. Then after that, you've got 5 times 4 squared plus 1, which is 5 times 16 plus 1, which is 81. That's definitely going to be the most challenging of these 3 that you see right here. Now, number 3, this one's probably going to be the easiest. There are no exponents, so you're going to have negative 4 times your x plus 24. Now, the important thing is with all of these, you need to put parentheses around the x if you're multiplying something with it in order to use the order of operations properly. So you have negative 4 times 5 plus 24 is negative 20 plus 24. So that's, positive 4. Then you have negative 4 times 10 plus 24. So that's negative 40 plus 24. So that is a negative 16. Then negative 4 times a 15 plus 24. That's negative 60 plus 24, which is negative 36. And that is it for this problem. All right, so this one we're going to be looking at solving. When we go to solve this equation, we see that there's something in the exponent. Now, if you guys remember, last semester, we looked at writing things from exponential form and changing them into logarithmic form. So just a little reminder, we have y equals, say, a to the x. If we need to solve something for, if we need to solve for x, say, and we can't in the format that it's written in, we have to then change it into log base a of y equals x, and then we get our answer. So it's that circular rewrite that we talked about. It goes both ways, and then if you have that base there, and that's the same base. So now we're going to use that knowledge to go ahead and solve this equation. However, the first thing that we see that we have is we actually have a 5 times this 3 to the x. So we're going to go ahead and divide out that 5. We're going to be left with 9 equals 3 to the x. Now there are two things you can do. One, you can look at that and say, 3 to what power is 9? Or you can do that rewrite. Doing the rewrite means I've got log base 3 of 9 equals x. And then you can do your change of base in your calculator. And then you'd get 2 equals x. The other way you can do it is, now this only works if I can change that 9 into the same base, which is base 3. So I can go ahead and change 9 to 3 squared, and then I have 3x, which if 3 squared equals 3 to the x, then 2 equals x. So those are the two different ways. If you don't remember the log way on this type of problem, you can approach it in the other way, that second piece that I showed you.